Hi, my name is RJ Balanga. I work at NASA headquarters in Washington, D.C. I am the Deputy Director for Spectrum Policy and Planning. So, as a Deputy Director, I take care of a lot of the operational things that go along in managing the organization, i.e., our budget, human resources, our workforce resources. But on the technical side, I'm also in charge of our domestic implementation and our domestic processes.
So my name is Jeffrey Hayes, and I originally was an astrophysicist at NASA. I still am at NASA, but now I've taken on a new position within the agency to act as a liaison between the science community and the space communication and navigation organization within the agency.
My name is Philip Baldwin. I am the Network Services Division Director, and I work at NASA headquarters for the Space Communications and Navigation Program. So my specific role is a strategic one. I provide programmatic oversight of NASA's communications networks, which include the Deep Space Network and the Near Space Network. And a day-to-day for me is making sure that we do the right things to taxpayer dollars, ensuring that we can communicate to the billions of dollars of investment and all the great satellites and science exploration that we do in human exploration.
Well, as everyone knows, NASA, we do a lot of space missions. Um, we're right now, we're going to the moon. We're trying to land on the south pole of the moon and utilize the lunar resources to help fuel and provide resources for a longer mission out to Mars in the future. Uh, However, not only do we do space, but we do a lot of science missions. We do Earth observing missions, taking a look at receivers that are flown on satellites, looking down at the Earth, doing a lot of different types of measurements. But we also have satellites that go out to other celestial bodies. We're sending something out to Venus in the near future to take a look at what their atmosphere is like. We've sent satellites out to Mars in front of a potential human exploration onto the Martian on the Martian surface. But we also look at the sun.
For the passive side, it tends to be on the Earth science side. They use SARS and LIDARs to actually look at very specific wavelengths in the radio band to tell them about to tell the science community about different types of both geology and also atmospheric science. So it turns out that a lot of the molecules in the Earth's atmosphere have very specific frequencies they radiate at, which are usually in the low frequency range. And making sure that those passive bands are protected, which is something that we're also very worried about because of the popularity of using radio for communications writ large, is something that the agency is actually working hard to make sure that those bands will survive for the next generation or two generations or n generations of scientists.
Yeah, so NASA, we have some core objectives, right? We want to advance science exploration, because that's why we have the Science Mission Directorate that focuses on science exploration, astrophysics, heliophysics, looking at the universe, the planets. But also we have the human exploration component, and that all wraps into science. With humans, we're able to go to the moon. We're looking at going to the Mars, and again, advance the human understanding of the universe. And so the organization I work in is an enabler. So we enable both human and science exploration by our communication.
We do have our own mission here in Spectrum, and we provide the overall planning, policy, coordination, and implementation necessary to ensure adequate access to frequencies and to the electromagnetic spectrum to support all of NASA's current and future missions. A lot of the bands that people don't realize are what are called remote sensing bands. And these are the bands where we do our Earth observations in. Those are most critical to NASA because these are very highly sensitive receivers that are operating in space, looking down, observing the Earth, observing the molecules in the atmosphere. And what it's actually receiving is not an active signal from somewhere else, like another radio that's transmitting. It's receiving the resonant frequencies of those molecules and determining how many of those molecules are within that field of view of that sensor's path. And because they are so sensitive, that interference occurs to our systems all the time. So we have to do our due diligence, and when we do our frequency coordination, ensuring that adjacent band operators do not bleed into our band. That way, and cause degradation or anomalies to the data that we're capturing. But also, we have to do our due diligence in the regulations and the development of spectrum regulations, both at the international level and at the domestic level. Well, one of the things, being a spectrum professional, it's not only about being a double E anymore, or getting an electrical engineering. Spectrum management, spectrum is getting very complex. With more and more users, more and more wireless systems out there, there's no more what we like to call white space. There's no free frequencies out there anymore. So everyone's got to be compressed or compacted into certain frequency bands. There's a lot of policy and negotiation that occurs. So not only do you have the technical skill sets that are required to do the job as spectrum engineers or spectrum managers, but you also have to have some legal expertise to understand how to read documents, what the interpretations of those documents are, but also need to know some policy and negotiation skill sets in performing that. There's a lot of research that also goes on.
I came to NASA because when I was a kid, that was the place to go. If you wanted to do something scientifically, you went to NASA. So, and that's a true statement still, right? So I'm very lucky. I actually do work for NASA. It's like weird. At some level, you're just, wow, I actually work for NASA. I actually have a badge that has a little meatball on it, which is very, very cool. We do have an intern program. SCAN has an intern program. The agency has an intern program. We're always looking for bright folks, and you don't have to be don't have to be where a NASA center is. You can come from Alaska or Hawaii or any place. Just apply.